All right, so again, just specific case. The origin, 0, 0, 0. You could initially name it O or just change it to O after, like I just did. The default starting coordinate is A, so if you forget to do it, it'll be kind of frustrating because you'll always be off by a letter, unless you actually go through the process of naming each one. 3, 6, 1, 4, 0, negative 1. All right, so we know that if we find the determinant of the equivalent 3 by 3 matrix, that would give us the volume of the equivalent parallelepiped. So let's see what that looks like. All right, and if you want, I don't think I made a requirement here for you to actually do that. Maybe I did. I don't remember. Select the points O, A, C, and back to O in that order to create a polygon. All right. So O. Oh, I missed one. And C. Oh, good catch. Thank you. I'm just trying to make it look a little bit like my picture. All right. So O, what do they say? O, A, and C. And we want to create a polygon out of that. All right. So the Polygon Tool, which is the one that looks like a polygon. All right. So select that first, then O, A, C, and back to O. All right. All right. We want to create a line parallel to OC through A. We just kind of learned how to do that. So we're going to select the parallel line tool. And if you want, you always start with a point first and then go to whatever it is you want to be parallel to. So we're going through A parallel to OC. Then we're going to do it again. Through O parallel to AC. All right, then the intersection of these two. I mentioned before that there's an intersection tool, so I actually pasted in what, because it's kind of a nifty feature. So it's just sometimes the diagrams don't really tell you too much about what they are. It's not always obvious, but if you hover over it, it'll tell you what it is. So in this case, we're looking for this guy here, and then we want to find the intersection between this one and this one. All right. So then we're going to create another polygon, OCAD. All right. So OCA, that new intersection point is defined as D, and then back to O to close it in. And so now what we have is a parallelogram. All right. It's just a different way of coming up with a parallelogram. All right. Or slightly different. A nice nifty tool is the Prism function. It works in this menu. I just found that it's a little easier to just type it in because I always screw it up. Basically, is really what I'm getting at. I always screw it up when I try to use this menu, so maybe you can get it to work. But basically, what we want to do is scale this base up to point B. And the Prism tool will do that. Right? So if it were a circle and you scaled it up to a point B, it would create a cylinder. Right? There's a lot of different features, a lot of things that you can do with this. In this case, we're going to get a parallelepiped out of this. So Prism, Polygon, OCAD, rather than clicking on points. Comma B, and then hit enter. And that's really all I'm asking you to do for this, because again, it's just to get a sense of what I want you to be able to kind of manipulate it a little bit and see what a parallelepiped head looks like from different perspectives. But I'm not really asking you to do anything beyond that. What you can do is you can look through your calculations here and see, you know, different faces have different areas. You got line segments, the edges that have different lengths, and so on. All right, but that's really all I would need you to do for this part. All right, so nothing too crazy for the second part. The first part wasn't that bad either. So, and